So hi, today we are going to start the DAC interfacing with 8051. So already in the theory class we studied what is meant by DAC. Is it clear? So that means by using the DAC, that is the digital to analog converter. So here in this experiment we need to generate the different type of the waveforms. So for example, it may be the sine wave, it may be the square, it may be the ramp, or it may be the triangular wave. So here again we need to start with what are the hardware kits we need to use for this experiment. So similar as the last one what we seen in the stepper motor. So you can see here. So here one is your microcontroller kit. So already this is already we discussed in the last experiment, that is stepper motor. So one is 8051 kit. Second one is DAC kit I needed. So DAC in the sense this kit is belongs to your digital to analog interfacing. So dual DAC is there. So that means here two DAC ICs are available. So in theory class we studied DAC IC, that is DAC. So DAC, that is a 08. So that means 08 again 0800. So that means this is a one IC, that is a DAC. One more IC is available here, the second IC. This is also DAC. That's why they are going to call this is a dual DAC interface. If you want, you can use both the ICs or you can use only one IC, that is left to you. Again same thing here. So this is the LM. So one more IC is there, LM4558H. So this is the op-amp. So already in the theory class we discussed whatever you are getting the output from the DAC, it will be the current. So by using the op-amp, it will help to conversion from current to the voltage. So this is LM458, conversion of current to voltage. So this is the provide the reference voltage for your the DAC ICs. So that means in this kit you come to know that here two ICs are available. One is the op-amp IC, one is the reference voltage going to get it by this IC. So this IC number is LM723. So next question is, how can I connect this DAC kit with your 8051? By using the FRC connection. What is my FRC? Flat ribbon cable. So in the last videos we seen flat ribbon cable, in the sense by using this cable we are going to connect it to your DAC. So where I connect the output in the DAC here. So you can see here output connections are available. So here OUT, output 1 ground, output 2 again ground. So that means by using these connections we are going to connect it to the CRO. So what is the purpose of CRO here? If you want to see the waveforms, at the time we are going to use the CRO. At the time here from the CRO I am going to connect here the probes. So that means one is the positive terminal. So that means red connection. I am going to connect it to the one end of the output 1 here. So second one black is nothing but I need to connect the ground. So here output 1, output 2 are available on the DAC kit. So that means you can connect two probes for the CROs to check the two outputs. So this is about your the DAC kit. Okay. So second one, again third one, we need the RPS. So this is your the RPS. So that means I need to make the power of this DAC also along with the 8051 kit also I need to make it power up. That's why what the hardware kits are needed. One is the controller kit, second one is the DAC, third one is your RPS, and one more is I need the CRO. So here you can see the slightly I will rotate here. You can observe the CRO also we need to use. So these four hardwares we need to use for interfacing of the DAC. Is it clear? So next one I will explain about how to make the connections and all. So now you can see how to make the connections here. So what we've seen in the last experiment stepper. So same connections are we need to make with the RPS with your microcontroller. So you can observe here already I told you in the last experiment. So this is my 8051 microcontroller kit. So this also I need to make it the power up. So how can I make the power up here? With the help of the RPS connection. So this is the power. So power socket of 8051. So this connection is coming from your RPS only. So this is DB9 connector, serial connector. It is coming from your RPS. So again already you know that if you want to dump your HEX file on the controller, again I need to use the one more serial connection. So this is connection is going to your computer. So this is a serial communication. So only these two connections I need to make it to the controller. Again, when you are coming for the DAC here, you can observe here. So this is a FRC cable, flat ribbon cable. So what is the purpose of this one? You need to transfer the data in between the controller with your DAC. So for that purpose, one end of the FRC I need to connect here, other end of FRC I need to connect it to the your microcontroller kit. So this way we are going to make communicate between these two devices. That means we can say transferring the data. Second thing is, already I said output of the DAC I need to take it from this terminal. So that means there are total 4 connections are available. One is the OUT1, output 1, next ground, next again ground, last one is the OUT2, that means output 2. We can measure 2 waveforms also. We can observe 2 waveforms on the CROs. So what is the connection of this one? We can observe very clearly. These connections are going to the CROs with the help of the probes. So that's why here I am taking the 2 sets of the probes. So that means one is the positive, one is the ground, again positive ground. That means here 2 waveforms we can generate. So here one red is going to the out 1, one black again ground, one more black it will goes to the again ground, one more red is nothing but it should be the output 2 connections. So total 4 connections we are going to connect here. So again, along with this kit also I need to make it power up. So with the help of this connector, with the help of this power cable connector, I am going to power up with the help of the RPS. So where is the connection is coming from? It is coming from the connection of this one. So you can observe this. Clear? So this should be very clear. So if you observe this power socket here, they clearly mention this is a plus 12. So sorry, this is minus 12, plus 12 ground VCC. So here you can observe the cables here. First is the minus 12 here. So minus 12 in the sense this is the green color. So that's why you need to connect, this is the green color cable. It has to be this knob. Because of this is the minus 12. Similarly, second one is the red here. Red in the sense plus 12 volt. That's why red, this one you have to connect to connecting wire to this knob. So what is the reading here? This is the plus 12. Similarly, third cable. So this is connecting wire. This is the ground label. Ground in the sense this black color, the connecting wire, you have to connect it to the ground for this one. So last one, this is the blue here. You can see this is the VCC. Blue in the sense this is the 5 volt. That's why this blue color, this should be the 5 volt. So here 4 connecting wires we need to connect for the individual respective knobs. So one is the 5. This is the ground, this is the plus 12 volt, this is the minus 12 volt. This one we are going to identify based on these labels. This is very, very important. Clear? So that means in the DAC there are the 3 connections are available. One is the power socket, one is the output from the DAC, third one is the connection between the 8051 with your DAC. So here 2 probes we need to connect it to the channel 1 and channel 2 on the CROs. Only this much connections you need to make in the DAC interfacing. Clear? So next one will check in the output, how to measure, how to display the waveforms on CROs.